In this video, we're going to look at formulas and naming for transition metals. So class opened with this bell ringer here, and all three of these are review from the last two lessons. So today we're going to look, like I said, at the transition metals. Transition metals are found in the D block, so we're looking at this area right here, plus tin, which is SN, which is located here, as well as lead, PB, which is located right here. So the transition metals can have multiple charges, and the charge of the cation is represented with a Roman numeral. And chances are you've seen Roman numerals before if you didn't recognize them. So let's take a look at an example. One of my favorite movies of all time, or one of my favorite movie series of all time, are the Rocky movies. And all 5 of the original Rocky movies use Roman numerals in the name, except for Rocky 1. At the time, I don't think they realized there were going to be multiple movies. But the number 1 is represented with an I. The number 2 is represented with 2 I's side by side right here. The number 3 is represented with 3, so not too complicated for the first 3 numbers. But when we get into 4 and 5, it gets a little tricky. So 5 is represented with a V. Let's look at that one first. And then 4 has the I on the left side of the V. So think of it like, I always think about it as subtracting 1 from 5. So I'm looking at this one right here. So that's how I think of it. 6, which is not on here, but 6 is V with the I on the right side. So I think of it like 5 plus 1, and then when I look at 4 with the V in front of the I think of it like 5 minus 1. That's how I think of it. There might be another way that you could come up with to remember that easier, but just know if you see a I before a V that it's 4, I after V it's a 6. But chances are you're only going to see numbers 1 through 5 for this. Okay, so when we read out the formulas, we follow the same rules as the monatomic and polyatomics. So I rewrote the rules here for you. We start by writing the cation first, followed by the anion. We determine the charge of each ion, and then we determine the ratio needed to make it a neutral compound. You should already have these steps in your notes. So let's look at a couple of examples here. So we have copper 2 chloride. So copper, Cu, has a positive 2 charge because the charge is in the Roman numeral here. Chloride has a charge of minus 1. So we're going to need 2 chlorides to balance this out. So our formula will be CuCl2. Just like before, we don't want to include the charges in our final version of the formula. All right, lead, Pb, and again, the numerals given to us here, so it's lead with a positive 2 charge. Oxide, oxygen has a minus 2 charge. This is already balanced as is, so our formula will be PbO. Let's look at one more. We have tin 4, and this is that tricky number 4 Roman numerals. So Sn plus 4, sulfide. Sulfur has a minus 2 charge. And look, here we've got the IDE following the rule as before. Actually, all 3 of these have the IDE following the same rule as before. When we have an anion, we change the ending to IDE. So for this one here, the last example, we need 2 sulfurs. Each sulfur contributes a charge of negative 2. So our final formula will be SnS with a 2. Now when we do naming, we use the formula and the charge of the anion to determine the charge of the cation. We put the charge of the cation in parentheses as a Roman numeral. And we'll do a couple of examples here in a minute that will help clarify this. And then, of course, we follow all of the monatomic and polyatomic naming rules. So let's look at 3 examples here. So the first one, we have cobalt and bromine. So cobalt on the periodic table is a transition metal. We don't know the charge, but bromine has a charge of -1. And we have 3 of them. So we need this to be a +3 charge, because right now we have 3 -1s, which gives us we need a +3 to cancel that out. So we need this to be cobalt with a +3 charge. So our name is going to be cobalt, and our charge here goes in parentheses, cobalt 3 bromide. And we're changing the ending here to IDE because it's our anion, and it's not polyatomic. Okay, let's look at the next example. We have lead, which is a special case here. So we don't know the charge, and we have oxygen. So oxygen has a charge of -2. Lead, we don't know the charge, but we do have 2 oxygens. Because we have 2 oxygens, we have 2 atoms, each contributing a -2 charge. We need this to be a +4 to cancel that out. So this is going to be lead 4, there's that tricky Roman numeral number 4, oxide. There's that ending that we change because it is a monatomic anion. All right, last example here. So I see something in parentheses, so this screams polyatomic. All right, and we have 3 of them. So I look this one up in my table. This is sulfate. Sulfate, SO4, has a charge of -2. And we have 3 of these. Okay. But we have 2 irons. All right. So this gets a little tricky, because not only do we have to determine the charge of this, but we also have to multiply that charge by 2. So let's do a little math here. So let's first look at our anion. Okay, let me bring this up here. So we have 3 times -2, which gives us -6. Okay, so now let's look at the cation here. So what times 2 gives us a charge of +6? Because remember, we want to cancel these out. You could divide, or if you're quick, you could just look at it. So I know that 3 times 2 gives us +6. So in this case, this is going to be iron, Fe, with a +3, because we have 2 of them. Oops, I meant to do that in blue, but get the idea. So this is going to be iron 3 sulfate. Now remember, when we have a polyatomic, we don't change the name, whether it's the cation or the anion. We just leave it as is. So it's still sulfate. You should have a practice worksheet. On the front side, you're going to complete either the even or odd problems. On the back side, you're going to complete all of the problems. On the back side of the worksheet, there's a mixture of monatomic, polyatomic, and the transition metals. So good mixture of everything. And then in the last 15 minutes of class, I'm going to give a short quiz. The quiz will be located on Google Classroom under classwork. And then for those of you that were actually here, you were supposed to find something quiet. But if you're looking at this at home, just do something quiet at home. That was supposed to be a joke, but it was a bad joke. That's all I got. It's a Monday morning when I'm recording this. So there you go. That's all of the transition metals.